Well, I'd like to give you some tips on building the BitSync system itself, and then also looking at a technique for bringing all of the intermediate signals out into a single cluster output. Our BitSync system is based on a bandpass filter that resonates at the bit rate. And Butterworth sounds fine. So we can make some initial configuration of that. Now it's also possible then, as you continue to extend or make the terminals more visible. Let's try this one more time. Definitely doing a bandpass. Trying to see the upper cutoff frequency appear. There we go. Now this particular filter is part of the express VI category. And express VIs are nice because they tend to do a lot of things automatically. Next, I'm setting up my waveform data type control for the signal input. The very first processing step in our BitSync subsystem is some type of square law device, and you can either use squaring for that purpose or the absolute value. There are some slight differences between the two, but they give pretty much the same result. Now if you look carefully, you can see a coercion dot showing a data type transformation going just into the filter. And for our purposes, that coercion dot can be ignored. Let's try that again. The bandpass filter, as I say, is supposed to be a very narrow band type response that's tuned to our bit rate. The bit rate is a frequency in hertz. We can simply set that directly to our lower cutoff frequency. Then the upper cutoff frequency ought to follow that bit rate value somehow. And what I'm illustrating is setting the upper cutoff frequency to always be 5% higher than the lower cutoff frequency. So I take the existing bit rate and multiply it by 0.05 and then add that to whatever the bit rate is, and that forms our upper cutoff frequency. Now again, the next major processing that goes on in our BitSync system is the comparison or thresholding of that filtered bandpass signal. And essentially what we're looking for is the zero crossings of that. For the narrow bandpass filter, it looks very much like a pure sinusoidal signal. So I threshold that and then use a backwards difference derivative. And the derivative operation ultimately can be used to determine whether or not the comparator output has just gone through a low-high transition or a high-low transition. In a sense, the derivative is doing an edge detection for us. Now you'll notice that it automatically inserted a data type converter, and that was switching from the so-called dynamic data type to the array data type. Dynamic data type is that blue colored trace popping out of the bandpass filter. All right, I'll look for any place where the derivative output is less than 0. So my choice was to look for the negative edges of the bandpass filter output. Now I'd like to look at these intermediate signals that I'm highlighting as additional outputs from this subVI. Now instead of cluttering up the subVI with a bunch of different waveform outputs, which is certainly possible, I'm going to go ahead and bundle these together into a single output, because they can always be conveniently unbundled in the top level subVI, or top level VI, excuse me. Now I'm setting up a waveform data type constant. I'm also giving it a specific name, and this is what will ultimately allow me to use the bundle by name node. That way I keep everything straight on which signal we're looking at. So even though the constants are big and bulky here, they really are simply saying set up something that looks like the waveform data type and give it a specific name. So at this point I've established the cluster in terms of what it should look like data type wise. We still need to actually get the signals applied to properly generate our output. So this particular connection then allows the actual signals to be connected into that bundle. So each of the constants that were used earlier is now essentially overriding those constants. Now here's one place where I guess it would be helpful to take care of actually doing the data type coercion manually, just to make sure everything is working out okay. So this conversion from the dynamic data type gives us all sorts of different options. All I need is a single waveform. All right, and the coercion dot disappears. Very similar operation then can be used for that. And ultimately then we can create an indicator, and that takes care of the intermediate signals.